Okay, hey everyone, this is Swix, and I'm giving a talk about Bun versus Deno, the new runtimes for the third age of JS. I've given this talk twice now, once at React NYC and once at Bloomberg. I think there is a half-life on this talk. It's one of the first talks ever on both projects, and there's a lot of interest in it. The recording on either of the instances were not very good. So I'm re-recording this for my YouTube and for hopefully anyone else who's interested in my thoughts on Bun versus Deno. Let's get right into it. So important disclaimers first is they talk by an outsider who hasn't built anything real with either project. I've just done a bunch of research and actually talked to both projects. So a few years ago, I wrote this thesis called The Third Age of JavaScript. If you want the full thesis, you can check out the URL on screen. And I also updated it a few months ago at Reactathon, where I gave people a framework for thinking about what's evolving in JavaScript. There's so many new projects, you need a framework to organize it. This is the best one I come up with so far. But one of the things that I really didn't get a chance to talk about was the evolution of runtimes. So when we talk about the third age, there are four broad movements: the standardization of the language, the development of the user ecosystem, the development of the build tooling and libraries, and then finally the development of runtimes. And today we're really concerned with the evolution of runtimes, which is heating up again after being chill for quite a while. So Deno was announced in 2018, when 1.0 in 2020, and Bun just released 2 weeks ago. So we are now well into the third age, and all this innovation is happening, and we're seeing the implications of that. So the first thing that we need to do is, I don't like talking about replacing things just because they're new. We should try to figure out what's wrong with the things that we have today. And there's probably no better person to talk about that than Ryan Dahl, who created Node.js. In 2018, he went to JSConf EU and had a talk about design mistakes in Node, or things he regretted in Node's decisions. The talk is available on YouTube, so you can click over if you want to see that. But here's the TLDR on the left. He apparently chose continuation passing style, like the error callback syntax, because he was impatient with waiting for promises to standardize. And he said that who could have done that. He regretted the lack of security, regretted the build system, and then a small set of other design decisions that he regretted as well. If you check the Deno docs on the right, he's actually gone and updated it a little bit. So there's some more regrets that he's listed on there, and we can kind of go through that as well. But anyway, so today we're going to talk about the table of contents. What is Deno? What is Bun? We'll do what they have in common, like what both of them are improving upon from the existing paradigm. Then we'll do compare and contrast, and then what is the future. This is my best attempt at a fact sheet on Deno. So what's on the left is the snapshot of the GitHub. So you can see it's pretty impressive. It's got 84,000 stars, 1,500 people watching, 4,500 forks, 700 contributors, and it's 64% written in Rust. There's a brief timeline in the middle where we've talked about how it was announced at JSConf EU in 2018. Exactly 2 years later, they announced 1.0, and then they formed a company in March 2021. And then most recently, last month, they announced their Series A with Sequoia. And on the right, you can see the Hacker News interest has been overwhelming as well. There are very few Hacker News posts that get over 2,000 points, and Deno 1.0 was one of them. And there's just a lot of interest in the major developments of Deno. In particular, it's not just company formation. Like, they've actually announced formal partnerships with notable companies like Slack, Superbase, and Netlify. And I think that's very significant for such an early company. Like, this is clearly a company that is run very differently from other kinds of early stage developer tools. Now we're going on to Bun. Here's the fact sheet on Bun. It is much younger. It's only about 14 days old as far as open sourcing. And it's about 14 days and 1 year old as far as project creation. 24,000 stars so far, 88 contributors, and mostly written in Zig, not Rust. And the main marketing for Bun, there are just two things broadly to know about. One, which is it is written for Node.js compatibility. So where Deno wants to make a hard break from Node.js because of the design decisions that we talked about earlier, Bun aims to maintain compatibility so that you can just run in place. And two, Bun is all about speed. That is almost 95% of its marketing is just speed in many different dimensions. So, for example, as a single server, it can take 260,000 requests per second. It is 20 times faster of an install compared to npm. Can bundle a million lines of JavaScript. It's got whatever 2 to 4 times faster starts than Deno and Node. It also has some dedicated speed metrics for React SSR tests and foreign function interfaces. So just a smattering of the use cases that you're going to use a JavaScript runtime for, which is all there. The speed claims in particular are all over its website. So if you go to bun.sh, you'll see three that he chose to highlight, and he actually sort of built in public, which is a really great way to follow along the development of a project. So first, it's server-side rendering React. Second is loading a huge table in SQLite, which is built into Bun. We can talk about that later. And then third, in foreign function interfaces, calling out to different languages. So the question really is like, fast is good. Fast is always better. But do you need this kind of speed compared to Node and Deno? Was that a problem for you prior, or is this a nice to have and we're picking based on the top metrics rather than what's good enough? So we'll talk about common features. One, I always love to point out that you can run them locally. So this is nothing new from Node. Node you can also run locally as a binary. The install is a little different for Bun. We'll talk about that later. It has HTTP2 support, ESM HTTP imports, web APIs. So everyone's kind of standardizing on front-end API inspired APIs. So fetch, request, response, WebSockets, and there's more standardization in process. We'll talk about that later. Environment variables. This is also a very nice developer experience feature, which is you include a .env file. You don't have to import a .env package to read that file. It just picks it up for you as you would just by convention. JavaScript, the language, has been slow to standardize TypeScript syntax or JSX syntax, and both Deno and Bun have gone ahead and just built it in. So even though it's not officially part of the language, it is de facto part of the language and is supported out of the box with no dependencies. You can just kind of include it and use it right away. It's got foreign function interfaces instead of the sort of no-drip system that Node.js had. And then it combines a bunch of tools. So all of them have some form of task runner, package manager, linter, bundler, tests. Bun does not have all of these, but it's pretty easy to see that it might eventually sort of add these on. Right now it's working on adding a test runner system. Okay, let's talk about Deno's unique advantages. I got 2 slides on this, and I'll spend a bit longer time on this, just because there's more to talk about. So Deno is running out of on a V8 engine, and this will be distinguished with Bun, which runs on JavaScript core from Apple. Running on V8 also means you can attach Chrome DevTools. It uses its own Deno FS and server APIs, which I sort of link to in these slide. By the way, I'll put the slides for this in the YouTube description in case you want to pull it out. There's just no way I can go into every single link and talk about it, but I think it's super interesting anyway. So for example, Deno is co-opting some web APIs that usually you use in a browser context to be used on the server. So what does location mean on the server side? What does web storage mean on the server side? And what does workers mean on the server side? Mostly for the same thing, it's like concurrency, but it just did not have a meaning on the server side until now because we're just choosing to take this web analogy as far as we want to go. It's got new permission APIs. I'll take a stab at showing this off because essentially by default, all the permissions for Deno are closed down unless you run a flag to open it. And you can even request for a flag and wait until it's granted. So here you can, for example, await the query, the permission to read this path, and you can wait for the user to grant it. And once it's granted, it will resolve, and then you can keep going. So that's a really nice way to wait for this. And I think that's indicative of the kind of security advantages that Deno wants to build in out of the box. It also has a docsgen command, which is super interesting, like a runtime that actually cares about building in docs tooling. And generally, it just has all around great docs. It has a manual, which is just a complete book for you to read top to bottom, which is super nice and detailed. It has tutorials for you to have isolated setups if you want. It has examples for you to copy and paste, little quick examples, and then even has thought about styling. which typically you won't see a server-side runtime think through for you. So that's really good. It's also got a meta framework that is first party. This is the sort of Next.js equivalent to for Deno's runtime, and it's based on the island hydration philosophy, which means that let me just take a moment to silence this because I am going to get distracted. I am going to get distracted. How do I turn on the silence effects? Focus for 1 hour. Awesome. All right. So the Fresh framework. So what is an island architecture? Typically in server-side rendering paradigms for anything in JavaScript land, there is a lot of duplicative overhead. Because when we render the page, we'll render the HTML on the server side, we'll send the HTML down to the client, and then we'll also send the JavaScript containing exactly the same thing that we rendered on the server. Even though we never re-render that again, this is all static. We shouldn't actually need the JavaScript for this, and so what Islands architecture does is it identifies areas where this is going to be interactive, and we'll just selectively hydrate those areas, and that's it. Everything else is server-side rendered, and no additional JavaScript is sent. So this is interactive, and the rest is not. The canonical post for Islands architecture is from Jason Miller, and you can read that on his blog, where this, and this are interactive, the rest are server-side rendered, and you don't send the JavaScript for those. Okay. Deno has even more stuff. It's just really, really caring about the ecosystem. Deno has a language server protocol for IDE integration. So all those amazing autocomplete and suggestions and stuff like that comes out of the box because it plugs right into LSP. No matter what editor you're using, you can take advantage of LSP to have great developer experience. You can use Deno as an embedded system inside of a Rust app. So if you want to offer JavaScript execution or extensibility inside of your app, you can embed Deno inside of your app. It has a third-party ecosystem. It has a package manager. So even though most Deno imports are from HTTP URL, so you can just kind of host it anywhere, they do have a central hosting service that they offer for you with pretty much everything that's Deno compatible here. So it is early days. It's only 4,900 modules right now, but I imagine there'll be a lot more in the future. It has a standard library, which again, it's trying to give you a lot more things out of the box, so you don't have to depend on random third-party ecosystem libraries. So there's probably more to show off here, but you can look at the crypto library that is using all these algorithms. It's also got, let's see, it's a standard library. It's also got like a date time library where it lets you do simple date math with differences and isleep and all that good stuff. All these are implemented without dependencies. It's also got node polyfills, so it can just it's got partial compatibility for you to port stuff over from Node.js because they know Node.js very well. And then the Deno to Node tool is very interesting for me. It means that essentially it's like a compatibility layer. In other words, if you're a library author, you probably want to just write for Deno because then you can use DNT to also write for Node.js. Whereas if you only wrote for Node.js, you could not do the same for Deno. Obviously, if you bet that Deno is going to be a thing. It has a deploy CTL CLI that you can deploy as a GitHub action, and it has a nice community that you can join. All right, let's talk about Deno deploy. That is the one big advantage. It was so big that I couldn't squeeze it in here. Deno deploy is deserving of its own slide. And Deno deploy is essentially the hosted Deno service that is run on the cloud. That's got how they're going to make money to support the project. It deeply integrates the V8 runtime with high performance web server to provide optimal performance. And it's a edge system. So every time you deploy, it deploys to the edge 34 regions around the world. I assume they use some other provider under the hood, but it's good enough such that you're going to be served from a region that's closest to you by default, which is extremely impressive. It has a playground editor, which you're going to demo in a very short while. It has a Git integration and crash logs. So in other words, switching from deploying something from Deno into production is based on a hash, and basically promoting something from preview into production is as simple as changing a pointer to the hash that is now production. Means there's no time to redeploy. It's extremely fast. There's also organization support, which is useful for serious business users. There's broadly gzip, automatic compression, runtime sockets, and it's got an interesting usage of broadcast channel for communication between regions, because you're serving all these Deno apps from different regions. If you need to talk between them, you have to use the sort of broadcast channel browser API on the server side, which again is a very interesting usage and creative usage of browser APIs. So let's go ahead and create a new Deno project. You can obviously import from a GitHub library. You can import from and export to GitHub. I just like to show off playgrounds because they're so simple. A simple Deno project is as simple as that. It's you import from a library. Here we're importing from the standard library with an HTTP server, and then we're serving a request and response of Hello World. I think if I hit play here, it's going to create a project. And it's going to say hello world in this kind of in this page. If I want to rename it, I can say hello Deno 123, and let's call this hello Deno 123. And this is a live server that went out to 34 regions around the world. So if I just punch it in here, I get that JSON response. If I did an edit here and I redeploy, that was the amount of time that it took to redeploy everywhere. And if I refresh, it's going to update accordingly as well. So that is as simple as it is. To me, this brings the experience on par with something like a Repolit, but better probably because it's an edge system, like it's deploying from the edge, and so it's incrementally better, and it's something that Ryan Dahl has mentioned in his blog post as something that you just want as a default. He had a really good presentation at RemixConf. Let's see if we can find it here, where he listed out the examples of like what is he looking for in terms of the dream stack, and it should be all these requirements. And basically, he's built Deno to fit the requirements. So if you want to think about the philosophy that he identifies with, check out the Deno talk at RemixConf. Okay. So what else do I have to show you? Oh, yes. So the other thing that is interesting in the playground is that he's also, so let's go ahead and get a new playground. You can serve JSON response, just like response.json. You can serve JSX with Tailwind included, and you can serve WebAssembly. I think the Tailwind stuff is really interesting because it means that he's also thought about styling. And you can sort of try that out here. So really, like literally, that is all you need to create a full website, as long as you don't need a database. There's a little bug here with the deploy, so I'm just going to go back to the server, back to the projects manager, and let's say we go to this one over here. Nope, we go to this one over here, and you see all this Tailwind CSS that just comes into a nicely styled web page. So Ryan actually runs his own personal blog from here with full styling and everything, because it doesn't need much else. And obviously there are guides to deploying with there are guides to deploying with databases if you want, if you need some sort of interactive CRUD based application. All right, I think that's all I had to say about Deno. Now we'll move on to Bun. So Bun, as we talked about before, there are two primary things that it's marketing. One is NPM compatibility, which means you can reuse all the existing packages. I did a live stream of Bun and people reported that they could use Next.js, SvelteKit, Remix, all that stuff from the Node era to the Bun runtime. So it means that it has good enough compatibility. I will point out that the compatibility actually is based on plugins that are written by them, and it's actually very partial. There are a lot of things that are not supported. So, for example, if you want to use any of these features within Next.js, Bun does not support it right now, even though it promotes Bun compatibility or Node.js compatibility. There's just a lot that you have to do if you are trying to rewrite Node.js as a single person in 1 year. Speed-wise, it's using JavaScript core, which apparently has 25 milliseconds faster speed. So there's a little bit of a discussion down in here, and there's a lot of discussion on Twitter as well. But essentially, the idea is that it's because you have this faster startup time, Bun is actually a better runtime to run, serverless functions or anything that requires much faster startup times. It's got built-in SQLite, which we're going to go on and proceed to talk about later on. It's got extras and bundling that you might come to expect from Webpack. For example, CSS modules, CSS loader. It's even got a TOML parser, which is a controversial decision, but not that major either way. It's got a much smaller ecosystem, of course, because it's a newer project. It's got a Bow.js. It's got the equivalent of an Express.js for Bun, and it's again, I think the main project sets the values for the rest of the project. So for Bun, obviously, node compatibility and speed are at its core of its values, so that those values transmit down to the rest of its ecosystem. So they're going to inherit the same values as well, with the same emphasis on speed. It's got temporary downsides. There's actually no doc site for Bun right now. It's just a giant README. There's no API reference, so you don't actually know exactly what Bun has. You have to kind of feel it out. There's no deploy docs. I was the first guy to actually ask, how do you deploy Bun? Because you said you can deploy to Vercel. I don't believe you. And right now, the answer to how do you deploy Bun is you deploy this gnarly Docker file, which is kind of gnarly. Cool. And the installation currently involves curling a bash script and then just sudo and then running it. Obviously, there's nothing nefarious in here, but it just kind of feels janky. Like you want to have the normal standard runtime distributions of Homebrew or whatever other installation, or like a single binary download that you want to install. Right now, the setup is a little bit more involved, so you have to run a bash script to just install Bun, which means deploying it is also that much harder. All right, SQLite. This is probably, as much as Deno deploy is a special thing that is special for Deno, Bun is focusing on persistence with built-in SQLite. SQL has been trending a lot recently as an embedded database, and I think deservedly so. And so why not embed the database inside of your JavaScript runtime? Seems like a novel idea compared to all the runtimes that we've had so far. So essentially, that just lets you run SQLite. It persists to a file that you can sort of inspect. And I think that's it. Now you have no excuse, but probably also gives you a hint as to if and when a Bun hosted service happens, this SQLite module is probably going to be a distributed SQLite, something like that, something that Fly.io already has. Let's talk about the community or the sort of governance of projects. Deno is a fairly mature project already, having been around for 4 years, and has a core team. Look at these are the Git commits of the core team. Whereas Bun is essentially a solo project that's been around for 1 year, and that's about it so far. So the race is on. Bun only open sourced 2 years ago, and you can see that the GitHub stars went vertical, so there's a huge amount of interest. But Deno has 4 years of head start on all of this. So I think there's only so much you can tell from GitHub stars, but I think this is probably reflective of each project's relative developments, and the level of interest in each project is very significant as well. Bun and Deno are not the only new runtimes. There will be a third one coming, which is kind of weird to say because Cloudflare workers have been around for a while. They just have not been open sourced. So you couldn't really use them locally, or you couldn't really inspect them, or you couldn't really reuse them anywhere else. Cloudflare, of course, realizes that, so they are announcing open sourcing, and they should be at open sourcing soon when Cloudflare's next birthday launch week is coming. Cloudflare also has a few years under its belt of offering distributed persistence primitives, which I think is super important, and I'll talk about that later. But here's the API for workers KV, which is a eventually consistent data store, and it's just as simple as get and set. Here's the API for workers durable objects, which is strongly consistent data storage. And then here's the API for Cloudflare D1, which is their SQLite embedded version built on top of those durable primitives. Let's talk about standards. So let's say Cloudflare comes out with a server-side runtime for JavaScript. Bun comes out with one. Deno comes out with one. All of them have different opinions as to which specific APIs they implement, and there are, let's say, a couple hundred to go through. Um, it would be really annoying for libraries to be built that run on one of them but not the others. And so everyone recognizes that there's a shared interest here to build an ecosystem that doesn't fork too much. And so there's a community group called the WinterCG, or Web Interoperable Runtimes Community Group. That's a collaboration primarily between um, Cloudflare, Deno, and all these other guys, including Bloomberg as well. So if you go onto the site, they've actually listed out the APIs that they want to standardize. This is really good because this is the first time that we're talking about web APIs on the server, and specifically across non-browser ones, but they also want to talk about the web as well. Notice, I think, so there's timer primitives here, there's crypto primitives here, there's stream, there's URL. I think all of this would be really good to just assume is standard within any library that is built for the third age of JavaScript. Notably missing here are anything to do with HTTP ESM imports. Not exactly included in here, and that's something that, now that I've talked to Dan Ehrenberg, who's on TC39 and in the WinterCG, they're currently focused on standardizing, as well as persistence primitives, like all that stuff that I just told you about workers KV and and SQLite embedded inside of Bun. Like none of that has any standardization, meaning that libraries that are written for these runtimes cannot assume, and so there's only so much abstraction you can put over them. So that will be annoying until such time that WinterCG can standardize persistence primitives, which, for example, Deno has kind of done. We talked about how Deno uses web storage or local storage as its persistence primitive, whereas Bun uses some SQLite module. Okay, so there's a lot of developments and a lot of interest in the future of JavaScript and the future of runtimes. And for the first time in 10 years, we have real choice and innovation, which is in the large a very good thing, and in the small a very annoying thing, because people now have a choice instead of not having a choice, and now you have to make choices. So I did do a poll. This poll reached about 8,000 people, and the people have voted, and they're sure that Bun is going to win. No, people are recognize it'll be split, and honestly, this just is a better reflection that just Bun has done a better job of building the public on Twitter. Therefore, more people on Twitter are more excited about it, and it just goes to show it's perfectly reasonable for people to expect that if you cater to them more, they will have more favorable opinions of you. That's why marketing is important. That's why I have a job. So what's common among all these, like even if a new runtime comes along, what it will probably have? The first is a trend that I've been pushing for a while, which is called collapsing of layers. My favorite example of this actually comes from Benedict Evans. He has a really good blog post called Platforms, Bundling, and Kill Zones, where he talks about how platforms usually start out with a small API surface area, and then we discover their jobs to be done, and we expand their definition of what they do. So the canonical example of this is word processors. When they came out in the 1980s, did not come with word counts, did not come with footnotes, did not come with charts. If you wanted any of those, you would have to buy them as separate plugins for $50 to $100 each, and you install them. But nowadays, what's on the right is what we have today. These are all standard feature sets of word processors. You would just not imagine a word processor without, I don't know, footnotes or word counts. That just makes no sense whatsoever. And similarly, I think the other analogy that I offer for platforms growing in scope is we used to sue Microsoft for including Internet Explorer with Microsoft and pushing that too hard. And now, of course, every operating system does come with its own recommended browser, and nobody has a problem with it. So likewise, with the standard state of JavaScript in the 2010s, or the second age of JavaScript, there was all this logo wall of just stuff, of tooling that people could mix and match and interoperate. And it would just be a little bit messy. There'll be a lot of choice. And really, I think all of us are just collectively decided that we just need all these features. So we want to collapse them into a single toolchain because we want faster speed and better default choices. So that's the first trend, which is that all these layers of tooling are going to collapse into a single binary, and that's most likely going to happen with Bun and Deno, and we're not sure about Cloudflare workers. So here's that thesis happening for Deno. Here's the mapping from the Node ecosystem, like using NodeMon or Prettier or ESLint, and mapping those to Deno lint, Deno format, or Deno run watch. Bun again doesn't have docs, so you have to kind of infer from from reading the README. These are the commands that are available now, which is the test runner that is available. But likely more and more of this will be covered as well for because of the sheer amount of competition available. The second trend from collapsing layers is edge first rendering in databases. So essentially, because the ground is shifting under our feet, server side runtimes are moving to edge runtimes. Therefore, the front end frameworks that that we know and love today will most likely also move to be renderable within edge contexts, which means that it has limited memory constraints, it's limited runtime constraints. And you want to deploy and render from the place that is closest to your user. That seems really good for speed, except for the fact that most of the databases that we interact with do still exist within a single availability zone. So what good is rendering close to the edge if you're still calling back to a single origin server for your data, right? So really, ultimately, you're going to have edge first databases that are co-located with your edge first rendering, and that is the thing that Cloudflare has uniquely figured out so far. Bun and Deno will probably go in that direction because they have to. Third trend, JavaScript containers. This is entirely Ryan Dahl's thesis, so just go to his blog over here and read that when you have the time. But the TLDR of it is that we used to share compute in VMs, then we discovered containers, then we share compute in containers, and now we are moving towards the V8 isolate as a unit of deployment, and we're sharing compute in ever smaller packages. Every single time we improve in the layer of extraction, we improve orders of magnitude in terms of cold start. We improve order of magnitudes in terms of bundling size because of how much we're assuming inside of the host machine. And therefore, we're improving orders of magnitude in terms of cost. My favorite example of this comes from pricing, from real world pricing examples. So I used to work at AWS, and AWS Lambda would have a certain amount of price. Let's call it X. AWS Lambda at Edge, which would be the Edge equivalent of AWS Lambda, would be actually 3 times of the AWS Lambda pricing. So it's 3 times more expensive. Now, if you flip over to when Netlify launched Deno functions, they actually launched Edge functions with Netlify Edge with 25 times cheaper pricing than regular functions. So if 3 times 25, that is a 75x improvement in pricing. Obviously, we're being extremely broad because those are actually the free tier pricing levels, and they get a little bit more complex with more usage. But it's roughly 1 to 2 orders of magnitude improvement when you're moving from traditional serverless offerings to an isolate cloud offering that Deno is offering. So again, just to push this point home, because the economics have shifted, because it is now cheaper to render on the edge than on a traditional serverless compute layer, frameworks will now move to take advantage of that fundamental infrastructural change in assumptions. And I think that's extremely exciting to call out and see evolve over time, because it's just math, it's just economics. And having economics precede code is very exciting for me because I studied economics before I studied how to code. Final thesis is FASAS, which is functions as a service as a service. Kenton, who's the tech lead of Cloudflare Workers, has been calling this out as a trend, which is essentially making the edge of every app, every SaaS service that's offered, programmable for developers. Like, what if you could offer all your end users a runtime to run some JavaScript to patch up the functionality, or to offer functionality that you couldn't do on your own? And that is that's an ultimate extensible thesis that Deno is also pursuing, called Deno Deploy or Deno Sub-Hosting. And they've already offered it with a bunch of well-known names, most particularly Slack. So you can actually see this in Slack's docs as Slack API. So I think they call it flexible automation for everyone. And it's in beta right now, but I think this is definitely compelling, which is essentially you can run edge functions on Slack without any other third-party hosting service. And that's just because it's programmable at the edge. Like the application, the Slack application that they ship to you is not just the one that they design for you that you have to take all their decisions on. You can actually program within Slack. And making that super easy to integrate is the general thesis for SaaS. For that to happen, or for this to succeed, the ecosystem has to win. So the standardization effort becomes even more important for libraries to just work whenever you're using it in Slack or Notion or whoever else is offering for SaaS. That is the ultimate vision for what this could become. And end user computing becomes end developer computing. All right, so that's the end of the talk. I typically have more links. Basically, just follow these two projects. I'm just a fan. I'm just floored by the ambition and the intelligence that's going into improving the next age of JavaScript, and I am happy to watch and I'm excited to see who wins. Cheers.